So as we have seen a cortical cataract, the stages of a cortical cataract and how it evolves from the early stages to the advanced stages and leads to complications, even complications like phacolytic and phacomorphic glaucoma. Now we go through the story of nuclear cataract. Nuclear cataracts are basically cataracts formed in the central portion of the lens. Central portion of the lens. Can you see the slit lamp picture? Here, this slit lamp picture also nicely shows you the Purkinje-Sampson images. So I'll detail to you. This is the Purkinje-Sampson image 1. This is the Purkinje-Sampson image 2. 1 is anterior surface of cornea, 2 is posterior surface of cornea. 3 is anterior surface of lens, 4 is posterior surface of lens. 5 is anterior surface of nucleus, 6 is posterior surface of nucleus. So there are 6 Purkinje-Sampson images. These images are nicely seen here, and you can see like this nucleus being like turning cataracts. Can you see? They are called grades. NS1, then NS2, then NS3. Can you see? This is NS1. NS1 is very faint. NS2 is bit more harder. NS3 is still more harder. NS4 is almost black or brown. NS5 is real black or brown. It is called cataracta nigra or cataracta rubra. Okay. Likewise, there is a grading of cataract. There is no staging, not like immature, mature, hypermature, not like that. Here it is more grading. So grade 1 is basically grayish. Grade 2 is yellow. Grade 3 is amber. Grade 4 is brown. And grade 5 is black. And by the hardness of the cataract, because today we do a procedure called phacoemulsification, where we emulsify this nucleus with ultrasonic energy and remove it during cataract surgery. In that, the nuclear cataracts are tough cataracts because when they become harder and harder, like a brown cataract, grade 4 or a grade 5, then lot of energy will be used to emulsify that nucleus. It cannot be done as easily as it is done in a cortical cataract. So that is the difficulty of doing phacoemulsification in very dense nuclear cataracts. That point I want you to remember. So we have gone through the grades of nuclear sclerosis. We don't even use the word cataract here, we use the word sclerosis. Nuclear sclerosis grade 1, grade 2, grade 3, grade 4 and grade 5. Okay. And what is this second sight? The second sight is anybody who is above 40, we'll presume a person is 45. What will he use? He will use reading glasses. Yes or no? He will use reading glasses because he has become presbyopic. Then slowly this person becomes 55. The person's age becomes 55. Then at 55 age group, what happens is the nuclear cataract develops. And because the nuclear cataract has developed, he'll develop a myopic state. And in a myopic state, this need for reading glasses goes off. He doesn't need a reading glass anymore. So in that myopic state, his vision becomes very well. Vision becomes very good. And that creates a feeling as if his vision has improved. But in the same patient, you check distance vision, it will be very diminished. Only near vision will improve. The patient will be able to read a newspaper very comfortably and say, he will say like my vision has improved because in the earlier years I was using a reading glasses for reading. Now without a reading glass I can read. If that is the statement of the patient, then you'll have to think that he has developed a second sight, and that is because of the development of a nuclear cataract. So second sight is caused by a nuclear cataract. Don't confuse this in cortical. Cortical will not produce second sight. Second sight is basically produced by nuclear cataract because nuclear cataract will produce a myopic shift in vision. Myopic shift in vision, and that creates good near vision. So basically, this is one slide which tries to explain to you the differences between a nuclear cataract and an immature cortical cataract. So nuclear cataracts and immature cortical cataracts, here it will be more amber. Here it will be more gray. The iris shadow is never seen in a nuclear cataract, but it is seen in a immature cortical cataract. The opacity, if you notice, it is more centrally dark. In a nuclear cataract, the center is the most usually involved area, but here it is not the center, it is multiple areas which are involved. And in a nuclear cataract, you get a myopic shift of refraction. You get a myopic shift of refraction. In a cortical cataract, you get a hypermetropic shift of refraction. Hypermetropic shift of refraction. In a cortical cataract, then the differences between an immature cortical and a mature cortical, they'll ask you. Here you will mainly rely on the iris shadow. You will say that the iris shadow is seen. Iris shadow is seen here, but in a mature cataract, the iris shadow is not seen. And as we go, like this becomes almost a chalk piece like red. That is a mature cataract. Then it will become like a milky white. That is an hypermature cataract. And that kind of changes we go through in a hypermature cataract. That can be nicely seen. This hypermature every time need not become a Morgagnic. So there are two hypermature cataracts: hypermature Morgagnian and hypermature sclerotic. So these two are the possibilities of hypermature cataract. And this is the basic differences. This will be constantly questioned to you in the examination. They'll keep asking you what is the difference between nuclear, what is cortical, what is immature, what is mature, what is hypermature, what is tumescent. These questions you have to answer. Next interesting feature is that, which I've already touched upon in cortical cataract, the final stage of cortical cataract. You remember we discussed phacomorphic glaucoma. Why a phacomorphic occurs? Phacomorphic occurs because of the intumescent stage. Intumescent stage of cataract leads to a phacomorphic. Likewise, what a phacolytic, why does it occur? It occurs in a Morgagnian. In hypermature Morgagnian, you get a phacolytic glaucoma. The other things I am not very expecting you to remember properly. They are nice to know points. Even if you forget, don't worry. But if it is a question is on a phacomorphic glaucoma or a phacolytic glaucoma, you have to surely be able to answer and tell the difference between which stage causes phacomorphic. In phacomorphic, the angle will be closed because the intumescent cataract, the swollen cataract, closes the angle. But in phacolytic glaucoma, there is too much of liquid protein. The liquid protein is causing the main damage to the lens. Another question which is asked in cataract here is subluxation or dislocation. We just discussed this in the first PPT itself. I'll revise it once more here. Subluxation is any touch with the patellar fossa when the zonules are incompletely disrupted. Incomplete disruption is subluxation. Complete disruption is a dislocation. A complete disruption is a dislocation. So these are the disruptions which we constantly see in a subluxated or a dislocated cataract. Thank you. With this, we almost complete the basics of cataract. We'll slowly go into the management of cataract in the further PowerPoints.